Hello and welcome back to a programming tutorial. We're going to look at Common Lisp again today. We had a look at a rock, paper, scissors application in Python a couple of days ago, so we're going to reproduce this program using Common Lisp. And if you saw the video from last week, we're going to use many of the techniques that we used then, but we're going to add some more in. We're going to introduce some new syntax, and I'm going to show you some of the cool features that I discovered while I was working with this. So if you've installed Emacs, just boot it up like this. If you haven't, I'll show you how to run this as a script if you're using VS Code or Vim or some other editor that doesn't have the full or has not been fully configured to work with Lisp in quite the same way. Now, unlike in previous videos, I've not actually come up with the program that I want to write as a whole yet, so there's going to be an element of live coding here, which is always terrifying. But with nothing more ado, we're gonna start off by creating a simple function called game, and it takes 0 parameters, and we're just gonna have it return 0. That is it. Let me bring up the REPL on the right hand side. Hopefully you can see that. I'm going to compile this using the space MEF pattern, and you'll see it pop up on the right hand side. Oh no, you'll see it pop up at the bottom there, great big uppercase game. So we know that that has been compiled, and to prove that, we're going to do hash, comma, not comma, quote, single quote, game. And this is going to look up in the function namespace, because that's what the hash denotes. Look up in the function namespace this symbol. And that's going to sound really crazy right now if you've not used Lisp before or any low-level languages. But just roll with it. We get a function object that's been thrown back at us, and this is what's really cool. If we click this, let's jump over here and make that bigger. We've got a name which is called game. It says that our argument list is nil. There is no next function. This function won't call another one after it of the same name. Its type is function nil. Values, this is pretty cool. Now if I click this, just the name thing here, and make it bigger. Nope, too big. We can have a look at the symbol that identifies this game. Is called game. It is a function. We can select unbind if we want, and there's no property list associated. If I click the game symbol, it tells me it's a simple base string of 4. It's got 4 elements. It's not adjustable, and here are the contents of it. So that's really, really cool. You can drill into basically anything in your program with incredible ease. But that's not what we're here for. We're here to just build a simple game. I just thought I'd show you what I discovered while I was preparing. So we're going to call game function here, and if I do space MEF, you'll see in the bottom left here 0. There you go. So we've got all the basic framework there. So what we want to do is we want to declare a variable that stores all of our values, which are going to be rock, paper, and scissors. So if you recall from the previous video, we would do that by opening a let block, and we will bind a name to a value. So this is going to be our options, and we're going to pass it a list, and we're going to literally use this quote symbol to say create a list in place. And it's still going to return 0. That's the last thing the function is going to do. We could have done this. And just to show you, so that has failed. That's not true because we've used the wrong equality operator, and we're going to get to that in a minute. Now that is true, because both of these, the list form here and the form, whoops, where we put a small quote mark at the beginning, they are equal. They're not EQ, they are equal. And it's just quicker, and you'll see so many people using the quote rather than the list form. Cool. So it is better to get into the habit of using the single quote to quote your list like that. But it is like calling the list function with these items, and it just builds a list in place. This is just some syntactic sugar here to shortcut around having to type list every time. It's an unusual symbol to use a quote mark, but you get used to it. So we've created our let block there, and we've got our options, but we want to create a special kind of let block where we're going to have more than one variable declared here. And actually the subsequent variables will depend on the previous variables. Now, because we are working in a let block, normally once you are inside the block you can have access to the variables, but you actually need to do something special if you are declaring variables all in one place and they depend on one another. What you actually need to do is a let star, and that enables us to do CPU choice, and we're going to have it pick from the options. So we want to do nth close this thing up here down for a minute so we can see what we're doing. And this is where the color of the parentheses that I showed you in the previous video really helps. So you can see, oh, this one, blue one maps there, that one there, or we've got a green one. So it really does help with the making sense of the parentheses. Now what we've done here is we've created a CPU choice where we're going to get the nth random number of length that, and we're going to do the make random state, so we get a new one every time. And we're going to call it the nth, get the nth number from options. So at this point I'm actually going to change this. Didn't mean to do that. So all we're going to do is we're going to create a string that contains a CPU choice, and we're going to expect to see it in the bottom left here. So I'm going to run this. We got rock, paper. We can see it changing. And we know that that is now working, so we'll get rid of that. The next thing we need to do is, still in our let scope here, is we need to get a user choice. Now, I'm actually going to handle this somewhere else, so I'm going to rely on a function that I've not created yet called the getPlayerChoice that we pass in options, and that's going to return and bind a value to player choice. So we're going to finish this off. And I'm going to create that function now. So again, all we're going to do is we're just going to print out what the CPU picks and what the player picks. You've not seen the first function yet, here on line 6. All this does is this, given a list, this will get the first item from a list. So when we pass in options, which is going to be our rock, our paper, and our scissors, options comes in here, and we're just going to return the first value in that list, which is going to be rock. So let's compile that, and we'll run it. So the player's rock, the CPU is rock. Player's rock, CPU is scissors. So that's all connected up. This is all the functions that we're going to write for ourselves. We just need to finish them off now. So we need to print something, asking the player for some input. A loop if it's not what we would expect, just like we did in the coin toss game. So we will format. Now, format has some crazy stuff you can do with it. You've seen in the previous video and in this one where we've got the tilde-a and the tilde% sign for putting an actual value and putting a new line in here. There is a hell of a lot more you can do with the format function, and I'm going to show you that now. Now, this is going to look mental, but I'm going to show you this running first before I explain it. So let's, we've compiled it up, let's run it. No more arguments. That's because I've not finished doing it. Now, here's where I made a mistake, and in the previous video I showed you the debugger here. So I made a mistake in my code. I've fixed it up. I'm gonna retry. Something's still not right. Did I compile it? No, I simply had not compiled it. So we compiled it, we retried it once we'd recompiled it, and it went off and finished running the function again, and we got this. And I'm going to change that. So it says, please enter either rock, paper, scissors. Now what this does here is this is some tricky little code inside the format function that tells it how to display a list. So this tilde open curly parentheses denotes that it needs to print out a list. This is where it says stop printing the list. So everything inside these curly parentheses expresses how elements in a list need to be printed out in a string. So if we remember that the list is just rock, paper and scissors, the tilde A represents rock. We then say tilde caret, this pointy thing up here, says it's like the separation character. So everything that follows this is what's going to be placed after the value, and then it's going to go back to the beginning again. So we get rock, comma space, paper, comma space, scissors, then it's done. And it's smart enough to know that that is the end of the list, see, so we only got 2 comma spaces here, and format has figured out how to do all that for us. So that is super cool. We don't have to do anything crazy about how we're going to display data from a list. We know it's coming out of a list. We know that format has the ability to display that. I could do this. If we recompile that, split, and have a look at the REPL, we run it, we'll see that it's put quote marks around the individual items. I'm not going to keep them there, I just thought I'd show you that for completeness sake, so you could put a little bit of style into this if you wanted to. So let's actually get some input. We're going to use exactly the same technique that we used in the coin toss. We're going to do an if. We're going to use this string down case readline thing, but we need to do something a little bit different than how we did this. Because we were just testing for one or the other, it was very simple to just say if it's heads or if it's tails, not a problem. But because we're now dealing with a list of things, we need to make sure that what the user's entering exists in the list. Now, we're going to have a look at the member function. So we're just experimenting here. I'm pretty sure I've got the arguments the right way around. Member, and another good reason to use Emacs is hints pop down at the bottom here, so I can do that and see the argument list in the bottom left. So it says member function takes an item and then a list. And then it also has this thing ampersand key, key, test, test not. We'll get into that because we're going to be using these. So yes, we do want to check that the item is the second parameter and then the list. So I have got that the right way around. So let's recompile that. Let's bring up the REPL. And we're going to run the code. So it's saying please enter rock, paper or scissors, so I'm going to enter it. That did not do what I expected it to do. What have I done wrong here? Oh great, I've killed Lisp. I'm going to restart my editor. Bear with me. This happens sometimes. I'm still learning myself. There's probably a way to recover from that, but I'm not sure what I did. Oh, that's better. We'll have the REPL down here. That's better. And yeah, this is the problem with live coding. I might do something and it won't quite turn out the way I was expecting, but that's okay. Part of the reason why I'm doing it live is showing you that although I'm not going to call myself a professional Common Lisp developer, I am a professional developer. Something went wrong here. So let's see. Let's try running that again. Input for thread 2, rock. Player entered rock, CPU rock. That's fine. Why didn't we get any output though? That is the question. I've compiled this right. Okay, let's get rid of this. I suspect it's because we've got this if here and it's returning nil from one of these two things and storing it in here, but it shouldn't do because there was something else. There we go. Not sure why it wasn't showing up in the editor, but if in doubt, just use the REPL here. I'll make that bigger too. So we entered rock, and it says it does not exist, but we know that rock, paper and scissors does exist here. So why are we seeing that it doesn't? And we're going to go back to the EQ and equals function. And I'm going to just jump down here. You might expect this to be true, this and this, but it actually says that it's nil. And if you can't see that in the bottom, I'll type it out here in the REPL explicitly. This is nil. And that's because although these strings have equal content, because they are unique strings in memory, they are not the same object. It has a little bit of identity here, like is this string exactly this string? And it isn't. This is where equal will come in. And this is true because instead of comparing two strings to see if they are exactly the same string, they are comparing the contents of the string and seeing if the contents of the string are equal, in which case they are. and that's what's going on here in our member function. We're actually reading a string in from the terminal, lowercasing it and saying, does this string that we have literally just got exist in the options, which it won't. So what we actually need to do is we do colon test, because this is a keyword for this function, and we're going to look it into the function namespace and give it the equals function. And when it tests to see if this string is a member of that list, it will use the equal function rather than the EQ function that it does by default. So if I recompile this now, get rid of that, and I run this, yeah, it's because we're dealing with values and outputs and streams. So let's just do it in the terminal. We're going to type game, we're going to enter rock, and it does exist this time, and we get player nil because formatting T returns nil. That's fine. This is exactly how we want things to be working. This just isn't what we want to be returning. So now that we've got it exists, what we actually want to do is wrap this up in a let. And that's another reason why I recommend using Emacs with Vim key bindings, this sort of space max or doom max. I was able to delete around parentheses, which deleted everything inside and including the parentheses, and then I just paste them inside another block of parentheses. It's super easy to move chunks of code around. So if choice is a member of options, we've got this. What we want to do then is return choice. And just like we did in the coin toss game, we want to do a little bit recursion. So if we have received something that we can use that is valid, we return it. Otherwise, we simply call the function again, and we form an infinite loop until we get something that we can deal with. So let's compile that, and I'm going to jump down here and run game. So players rock, CPUs rock. Let's run that again. I'm going to put paper this time. So the players paper, the CPUs rock. I'm going to run this again until the CPU enters something that isn't rock. So I entered paper, cool. So the randomization's working, the user input's working. We're basically there now. All we need to do is just determine the victory conditions. And we're going to replace this with the actual body of the function that we want to use. And in our previous Common Lisp video, we talked about if, and we talked about when and unless, and cond. And cond is what we're going to use today, because there's more than two ways to win this game, and there's the concept of a draw. So we need to do a lot of different things. So cond is the branching structure that we want to use here. I'm going to create a new line here just so we can see what we're doing. Now, the easiest condition is that a little bit easier to read. So in this particular bit of code here, we are the way cond works is we open the parentheses, we call cond, we then open parentheses and put our condition. So this equals CPU choice player choice. If this is true, we want to say it's a draw because both players have entered the same value. So that is one set of parentheses. We do another set of parentheses for what we want to do if this condition is true, and we close the parentheses for this. Now, we're going to do our first condition, second condition, sorry. Because what we're going to do is we're going to put all the victory conditions, all the ways in which a player might be able to win. So if it's not a draw and none of the victory conditions are else case or otherwise case, is going to be, you lose. So just like we did here, we're going to copy this. And we're going to do and here. So it looks a little bit crazy because there's a lot of parentheses. I'll see if I can, so our check is the logical AND of player choice equaling rock and CPU choice equaling scissors. So what we're going to do now is we're going to change this. We're going to copy this. Copy it again. So we can see, if we zoom out a little bit, just to get all this on screen, we have a condition to check for a draw, check to see if the user has entered rock and the CPU enters scissors, so that means that the player wins. The player wins also if they pick paper when the CPU picked rock. They also win if they picked scissors when the CPU picked paper. Everything else, this T is true, basically, if none of the other conditions were true, you lose. So let's compile this up and run it. And we're going to run it here in the REPL. I'm going to enter rock. I lost. Now, I want to know why I lost, so we're going to be a little bit more explicit. So I've just recompiled that now. We're going to run this again. I'm going to enter rock. I lost, but I think we're not getting stuff printed out properly, so let's do that. So let's enter rock. I entered rock, CPU entered rock. It's a draw. Let's do that again. I entered paper, CPU entered rock. I win. Okay, so I've been pretty lucky there in the way the randomness worked out. So let's close this down. Minimize this just a little. Hopefully you can still see that. It's 43 lines all told. And I'm allowing spaces so it can be read easier. I've got some stuff here. Let's be a little bit more specific. Let's change the string here. You entered CPU entered Forgive me for being quiet for a minute while I finish this off. Just going to make sure my parentheses are balanced, which they are. And I need to change this. That all looks good. Let's save it. Let's open the REPL. Let's recompile it. I wonder where that nil's coming from. Oh well, probably not a big deal. It all seems to I want to know why we lost. Sorry, I haven't done this correctly. There we go. Let's try it again. Right, okay. We have another bug because I have forgotten to pass the actual parameters in here. So this needs player choice and CPU choice. We compile it and we jump back to the debugger. And just like I showed you before, if we retry, scroll down. Nope, that was up. So you can see here when we caused an error, format error, that's where the debugger entered. You can see when I fixed it, I recompiled it. You know, it's recompiling the game function. It asked me to enter rock, paper, scissors. I entered rock. The formatting got a bit screwed up when the debugger triggered, but you can see I entered rock, CPU entered something. So let's go to the end of the line. It's a draw. We both entered rock. and that was the problem. So let's try this again. Rock. It's draw. It's a win for me. It's a win for me again. Let's try scissors. Finally, I lose. There we go. So we can now see that everything works. We've had draws, we've had wins, we've had loses. Everything seems to be working as intended. So let's close that. And you can see here that actually if we take 4 lines away from here, it's 37 lines of code. We've got some spaces and some comments here. But there's not much more to it than that. Some of the new things that we need to make sure that we've understood is we're familiar with this. The idea of let's member is a new concept we've had a look at. We're seeing if an element exists in a list, and because Common Lisp is a very generic language, it's very general purpose, it gives you a lot of flexibility and freedom. It makes sensible defaults, but you have the right to override and change things to work the way you want it to. And sometimes when things aren't behaving and things aren't seeming to do what you would expect them to do, it's entirely possible that the function that you're calling needs to be given some keyword arguments with a different function. You see this sort of thing in JavaScript and Python, where you might be doing various sorts. JavaScript, I believe the last time I used it, it used an alphabetical sort wherein 1 and 10 would come before 2 because 1 and 10 is alphabetically smaller than 2. And that might not necessarily be what you want if you're trying to do numeric sorting. So in JavaScript you would pass a function in and have it sort that way. It's basically the same principle. In Python you might use a sorted method and pass in a key function, a lambda function or something. And it's exactly the same here. What's going on, we're basically saying we're overriding how it determines if something is a member. And this could just as easily, this equal could just as easily be a function that we've created ourselves. So it's totally flexible, but with that flexibility means that you have to understand how to override it if it's not doing what you want it to. The other thing that we want to look at is this let star. If we took that away, all of this wouldn't work because CPU choice is depending on options, which is defined above. And it's the same here with the player choice because we're relying on the options that are created here. We need to use let star. If we weren't using variables that depended on each other, that'd be fine. We could just as easily have done something. If we were doing something like this, x is 5, y is 2, name is Neil. That's fine because none of these depend on each other. They're just a series of variables being created. However, if we are creating variables that depend on one another, this let star is syntactic sugar because otherwise we would do this. And that would be how we would have to do things with these nested let things, and that gets pretty crazy. So it's much nicer to just do a let star than this nested stuff here. So with the member, the test, the let star, the only other thing that we've introduced here that we didn't see previously is cond. And you know, it's every item in the cond is like a list with these parentheses that has a test and then a body. And this is super simple. We, in subsequent, no, I have forgotten to comment that. Sorry about that. We use the AND function to say there's two things that have to be true for the body to execute, so that and that. Same here. And T being the true object will always be true. So if any of these are false, true always evaluates true, so this will run if none of the others have. And that's it. That's all there is to it. I'll make sure that I've copied this code into the video description so you can copy and paste it if you want to. I highly encourage you to write it out yourself and try it. However, I did say that we would have a look how to run this if we're not using Emacs. So I'm going to shut this down because I know that all this works now. So all we're going to do is we're going to pass the script parameter to SBCL, and we're going to pass in the path to where the file can be found. For me, that is in my Quick Lisp folder, local projects, rock, paper, scissors. So I'm going to enter rock here. You entered rock, CPU entered paper, we lose. So if you're using VS Code or you are you're not using something that has the interactive development features that Emacs does, just type it out in your editor and run it with the SBCL script command, and you'll get to test your application. And with that, we are done for today. I hope that was interesting, and if you've got any questions, find me on Twitter, Neil_Munro, or just send me a comment in the video. Thanks.